Welcome to the next episode of the Introduction to 6502 Assembly Programming series. In this episode, it's going to be fairly short. We're talking about the first status register. Our first register, which is the status register. The status register is probably one of the most important, probably second most important of the registers in the 6502, but it is rather critical to understanding some of the more complex operations in the device. So let's take a look and see what it is. The status register is a register that's updated after most instructions that contain information, and it has the results, has information about the results of the last operation. This isn't universally true. Certain instructions affect the status register, some don't. And as we go through each instruction, I'll designate which bits in the status register get affected on those instructions, and that's sometimes important to understand when an instruction will affect the status register. Right now, most of this is probably a whole bunch of nonsense, doesn't make sense, why or how this even works. So let's take a look at some of these bits in the status register, and it'll start to make a little bit more sense. First bit is the C bit, which is the carrier not borrow bit. This bit is set when the result of the last operation resulted in an unsigned carry. So if you remember back to the first episode when we were learning to count in binary base 2. We started at 0, we incremented to 1, and then we incremented to 1, 0, and we said, that carried from the 1's place to the 2's place. In this case, that is not a carry in terms of the 6502. The 6502 operates, like we mentioned in the last episode, on bytes. And so if the result of the last byte had a carry, had a 1 that needed to propagate to the next bit, but since it only has 8 bits, if something rolled over from a 1 to a 0 on the 8th bit, it needs to store that information somewhere, and so it stores it in this carry bit. We'll see the carry in a bit more detailed interaction when we look at some of the instructions like increment and add and those. But for now, it's when a byte results in a mathematical carry. The Z bit is the 0 bit. This flag is set when the last operation resulted in a 0. And that could be from an addition, that could be from an increment or a decrement or a load. Maybe not a load, I don't know, I'll have to look back but to see which instructions affect the Z bit. But if the last operation resulted in a 0 being the result, then the Z bit is set. These 4 in the middle, the 1, B, D, and I, are really not used by most developers. Some of them are specific for interrupt handling, which is a more advanced use case and is kind of outside of the scope of what I want to cover for this class. So we're not really going to talk about those here. Most people that are interacting with those types of operations on the CPU are probably already fairly comfortable and familiar with assembly programming enough that they don't need me to cover it. So we're gonna skip that. And the 1 is just always set to 1 in most 6502 implementations. The V bit is an overflow bit. It means the last result of the operation resulted in an overflow, which isn't quite the same as a carry. depending on the operation. This bit isn't used or implemented in many controllers, and so we're not going to really cover it in any detail in any of the slides in this class. In most cases, you're going to use the carry bit instead. And the last instruction, or last status bit, is the negative bit, the N bit. And that just means the result of the last operation resulted in a negative number. I think we cover the numbers in one of the future sections on how you determine whether a number is negative or not in a lot of detail, so we won't cover it here. But the 6502 does recognize negative and positive numbers, and so if the result of the last operation was a negative number, then the N bit is set. And that's it. 8 bits inside the status register. The carry bit is going to be the one that's used the most probably, followed by the Z bit, the 0 bit. And then sometimes, very rarely, you'll use the negative bit. And the rest aren't really used. So, yeah, we'll see them in more detailed use as we go through the instructions. But kind of understanding what they are is important before we get to those instructions. The status register is always set by the hardware and is not set by the user. And each operation that the computer or the ALU does, if that instruction updates the status bit, then the status bit will get updated for whatever operation that happened. All right, next section that we're going to talk about is the accumulator, next register. The accumulator is probably the most important register to understand in the 6502 assembly. It's kind of the way the machine does everything that it does. And so, yeah, that will be a much more intense session than the status register, and I look forward to sharing it.